Congratulations, you've made it to the last video of our Vocabulary Lesson 2 on operators. So at the end of this video, you can either go back and study some more, or hopefully you'll be ready for a test. But what I want to do is just kind of point out a couple things that's important to know. So first of all, the reason we want to understand what words connect to operators is because in algebra what we're doing really is we're going to learn how to make equations to solve problems. And so when we hear these words in real life and in class, we need to make equations. So we need to understand what operators go, or what words go with what operator. Now there's one in particular that I want to show you. It wasn't in the Quizlet flashcards, so I want to just go over it. It's called at the same rate. So it's in this column. It means equals. But here's a good example. First, let's say that you are traveling at 25 miles per hour. So 25 miles in 1 hour. We would write like that. Now, somebody says, well, what if I travel for 5 hours at the same rate? Well, what you can do is you create an equal sign, and then you use the same units. You put the units here, miles, and hours here. So then you can answer questions. So let's say, how many miles, so that would be your variable, how many miles will I go if I travel for 5 hours? Okay, now you have a nice little equation, and you can get rid of the units, make it a little simpler on your eye, and then you can solve. Okay, I'm not going to do that right now, but you can solve, use the calculator if you want, and bam, you've solved the problem. So by knowing the word and knowing that you can use an equal sign, it takes something that sounds a little complicated and makes it rather easy. Okay, so that's one thing I wanted to point out. So you should know these words. You've gone through most things, and you heard a little bit about an inverse operator. So we know that if we do, let's see, if we do 4 squared, so we're squaring 4, and the word square, by the way, comes from the idea of a square. If the distance on this side of a square is 4, then we also know the width and the length are the same. So the area is just 4 times 4. Okay, 16. Well, that's what 4 squared means, or 4 raised to the power of 2. So we use these words squaring and power to refer to the exponent. So 4 to the power of 2 is 4 times 4, just like area. Okay? Now, the inverse operator is the square root of 16. Okay, and then sometimes we don't, but you could think of a 2 right there. And we want to know what number times itself is 16. So that's 4. And if you watch the video long enough, you'd know that it could be a positive 4 or negative 4. Okay, now a cube root. What is a cube root? Well, let's talk about what does it mean to cube a number. Let's take 3. If I raised 3, actually, let's take 2. If I raised 2 to the 3rd power, we would call that cubing. And think of it this way. Think of it as an ice cube. An ice cube looks like this. It has a depth. It's 3-dimensional. Okay, it has a depth. So if the length was 2, then the height is 2, but the depth is 2. So to find the volume, it's 2 times 2 times 2. You'll learn this in geometry. You don't have to know that right now. But that's what this means. 2 to the power of 3 means 2 times 2 times 2. So what the language, which is what we're trying to get at today, this means cubing. We're going to cube 2. So the cube root is the inverse function. So let's see, what's 2 times 2 is 4, times 2 is 8. So the cube root of 8 is 2. Okay, so that's what we mean by cube root. Okay, so you watch videos for everything else. What we want to do is make sure that you know that order operations are the rules. If you have like 7 minus 3 times 2, you need to know that you have to do 3 times 2 first. If you had 2 times, let's see, no, that's not a good one. 2 plus let's say 6 divided by 2. You need to know that you need to do the division first. If you did 2 plus 3 squared, you have to do the exponent first. So to remember that, we come up with this thing called an acronym, G-E-M-A. We kind of call it GEMMA. But G means do the grouping first. Anytime. Sometimes we have nested, what I call nested groups. Probably my example is not a very good one, but let's call this let's just call this division here. Sorry about that. I'm winging it here. Let's call this division. So what you'd have to do is do this group first. Let's put a 5 out here. You'd have to do this group, then you would do everything inside of this group, and then finally you would take that result and subtract it from 5. So we're doing the grouping first. The next thing is exponents. E for exponents. If this was squared, for example, then you would find this number and then square it before you would take the result and subtract it from 5. Now the M, this is what I really wanted to talk about. The M means multiply, but it also means division. Okay, because division is an inverse operation of multiplication. So division and multiplication come after exponents, but they also come before, because the A means add, but it also means subtract. Okay? So whenever you hear order of operations, that's what the way to remember that is GEMMA. So these things kind of go together. Okay, now finally, here's a question for you. Think about it. Is rounding a number, if I round this to the nearest 10th place, so what that would mean is I want just to this accuracy. So I look at a 4, it's below 5. So I'm going to say that this number is approximately 3.2. So it sort of seems like an operation, but we're not really applying anything. So it's called rounding. So it's not so important to know whether or not it's an operation or not, but you need to know that you're kind of making a slight modification to the number. Then the last thing is simplify. Let's take the number 4 over 12. If we simplify it, we might see that 4 is 1 times 4, and 12 is 3 times 4, and 4 divided by 4 is 1, so we get 1/3 times 1, or 1/3. So what we're saying is 12 over 4 equals 1/3. Have we really changed the number? Okay, it sure feels like an operation, doesn't it? That felt like work to me. It felt like math. But did we really change the number, or just to change the way it's dressed? Most of you probably know that 1/3 is 0.333 forever. So what is 12? What is 4 divided by 12? Well, let's just take a quick look. Okay, so 12 doesn't go in the 4, so we put a 0 there in the decimal point. We put a 0 here. Now, 12 does go into 40. 4 times 12 is 36, but the difference when we subtract is 4. So if we bring down another 0, guess what? We're repeating. And we just keep going like this forever. Okay? So what we end up with is 0.3331 equals, 0.333 forever equals 0.333 forever. So we didn't really change anything. We just changed how it looked. So at some point, the reason I point that out is that adding, subtracting, multiplying, usually these things are making some kind of alteration to the value or combining values to come up with a new value. That's what an operator is. So you might find more operators as you go through the course. But that's what you want to, that when we use that word operator, that's what we're talking about, is doing some kind of mathematical thing to change a number. Okay, so thank you for listening. I know that's a lot, but you can do this. So keep up the good work, and when you're ready, if you want, go back and play that game some more until you really get to know these words. When you're ready, ask for a test. Good luck.